So we're going to summarize and review this unit. First of all, we're going to start off with some factoring tips. Recall the first and most important thing is to common factor first. Then, if you see that the a value is 1, or you see a difference of squares, we can then use a shortcut. You don't need to use the shortcut, and if you don't have a difference of squares or an a value of 1, we can use decomposition, and that's the method that we use where we find the magic numbers and break up the middle term into two other terms. So first we're going to look at, can you completely factor an expression? So let's go through example 1. Common factor first. There are no common factors for 5, 18, and 8. And there isn't an x on the 8, so there is no common factor for the variable. We also see that the a value is not 1, and there is not a difference of squares here. So we need to use decomposition. We need two numbers that add up to 18 and multiply to give us negative 40. So two numbers that add up to 18 and multiply to give us negative 40 are positive 20 and negative 2. So let's rewrite our expression. We have 5x squared plus 20x minus 2x minus 8. Next is to factor by grouping since we have 4 terms. In our first two terms, we have a 5x, that's common. That leaves us with x plus 4. And in our next two terms, we're going to take out a negative 2, which leaves us with x plus 4. We have x plus 4 as a common factor. So finally, we get x plus 4 times 5x minus 2. B. So let's see if we can common factor first. And in this one we can. And since the leading coefficient is negative, we're going to take out a negative 2. And that leaves us with 9x squared minus 1. We see that 9x squared minus 1 is what we call a difference of squares. So we put down two brackets. We square root the 9. So that gives us 3 that we put first. Put an x beside the 3's. Put a plus and then a minus. And then square root the 1, which is 1. And there is our difference of squares. For 9x squared minus 1, we get 3x plus 1 and 3x minus 1. Next one. We have x squared minus 2xy minus 48y squared. There's no common factor in this one, but we do see that the a value is 1. So we start off the same as decomposition. I need two numbers that multiply to negative 2, and the two numbers must multiply to give us negative 48. So those two numbers are going to be negative 8 and positive 6. And since the a value is 1, those magic numbers are the numbers we're going to put in the brackets. So we end up with, and all we do is write down the x here. So what I would do is write down both the brackets. We're going to put an x here because we have an x squared. We'll put a y here at the end. And negative 8 goes into one of these and positive 6 into the other. And that's using our shortcut. If you don't know the shortcut, you need to use decomposition as we have shown in example A. And D. This one is one you haven't seen before, but if you look closely, we notice that each of the terms has a 2x minus 1. So if I take out the 2x minus 1, I'm left with an x squared plus 7x plus 12. That's a quadratic, so that can still be factored. So we have 2x minus 1. And since the a value is 1, we can use a shortcut again. So we need two numbers that add up to 7 and multiply to 12. And those two numbers are 3 and 4. So we put in our x's, and then we put in plus 3, plus 4, and we're done. Finally, can you determine the zeros, the axis of symmetry, optimal value, and vertex for a quadratic algebraically using factored form? And then, can you sketch the graph using the zeros and the vertex? So let's quickly go through that. So in order to get the zeros, axis, symmetry, optimal value, vertex, we need to get our equation in factored form. So let's start by factoring the expression above. First rule, common factor. I can take out a negative 2 from that expression, and that gives me x squared minus 2x minus 24. Since the a value is 1, we could use a shortcut, but I'm going to use decomposition just to show that one more time. I need two numbers that add up to negative 2 and multiply to negative 24. So those two numbers would be negative 6 and positive 4. So we split up our expression. We get x squared minus 6x plus 4x minus 24. That's because we split up the negative 2x into negative 6 and 4x. Next, we factor by grouping. So our groups are x squared minus 6x and 4x minus 24. We can take out the common factor of x, which leaves us with x minus 6, and take out the common factor of 4, which leaves me with x minus 6. Next, we have negative 2. Take out the common factor of x minus 6, and we have x plus 4 as our final factor. Now let's get to the problem. We want to find the zeros, axis of symmetry, optimal value, and vertex, and then sketch. So step number 1, to find the zeros, we're going to let y equal 0. So we have 0 equals negative 2, x minus 6, x plus 4. Setting each factor equal to 0. So x minus 6 equals 0, and x plus 4 equals 0. If we solve each of those linear equations, I get x1 equals positive 6, and x2 equals negative 4. There are our zeros, which can also be our x-intercepts. Once we have the zeros, we can get our axis of symmetry. Remember, that's x equals x1 plus x2 divided by 2, the midpoint of the zeros. So 6 plus negative 4 divided by 2, which gives me 2 over 2, which is equal to 1. So now we have our axis of symmetry. Finally, we can get our optimal value by subbing in the axis of symmetry into our original equation. So if we go back to the top, our original equation was negative 2x squared plus 4x plus 48. So y equals negative 2, 1 squared, plus 4 times 1, plus 48. So that gives us negative 2, plus 4, plus 48, which tells us we have an optimal value of 50. And therefore, our vertex for this quadratic or this parabola is 1 and 50. So now we have our 3 points, our first 0 at 6, our second one at negative 4, and our vertex at 1 and 50. So plotting those 3 points, so let's say this is negative 4. So as an x-intercept, that's negative 4 and 0. Let's say this is 6 and 0, and this would be 1 and 50. So we're just doing a sketch. There we go. We see that the parabola opens downwards. So let's go back to our equation. Our a value is negative, which means the parabola should be opening downwards. So this looks correct.